Let's look at some word problems this time. In example 6, we're looking at a physical science example. Height of a thrown object. A rock thrown upward with the initial velocity 50 feet per second from 10 feet above the ground has a velocity modeled by v of t equals negative 32t plus 50, where t is the number of seconds after the rock is released and v of t is in feet per second. A. Determine the distance function. Oh, guys, do you remember? We often start with the distance function. I was going to write d of t, but they said, hey, name this v of, not v of t, I'm sorry, h as a function of t. Well, it makes sense because it's a rock thrown vertically upward. So what's changing is height. When you first throw it upward, here's me. I'm gonna throw a rock upward. It's gonna go up, right? But at some point, it's gonna come back down. So we can think about the distance as how far away is this rock, or how high is this rock from the ground. So they're using h of t, I guess, for height. But let me tell you what we remember from our previous lessons, that if you wanted to find v of t, remember we have to take the derivative of the distance function or the height function, right? So what they gave us, that v of t, is actually the derivative function. So we need to go backward. We see we need to go backward. So do write this down for me. Oh no, Siri. Write down that h of t is equal to the integral of v of t dt. Okay? So what we're going to do is we're going to find the antiderivative of negative 32t plus 50 dt. And of course, we're going to have to write down the plus c, but I think they just gave us a little clue here. They did mention, did they? 10 feet above the ground is where it was in the beginning. So what I'm going to do is, after finding the antiderivative, I'll use the fact that h of 0, at time 0, it was already 10 feet above the ground. How could that happen? I don't know. Maybe somebody is like standing at a 10 feet height. Or maybe, oh, hold on. Maybe someone like myself who is like 6 feet. I'm not 6 feet. I'm sorry. I'm lying. I don't know. Maybe like somebody's standing on something. So this rock or this object is already 10 feet above the ground. Okay, so let's go ahead and find the antiderivative first so that we can look for what c is, find what c is. So write down negative 32t, but we must go up on the power, right? So go make that squared, t squared, because it was t to the first power. You have to go up 1 and make sure to divide the whole term by the new exponent. So that's good. Next term, plus 50. That will be plus 50 t to the first power divided by 1. It's just going to be plus 50 t. And then don't forget to put the plus c. Okay? All right, let's go ahead and simplify this a little bit. If you do negative 32 divided by 2, would that be negative 16, right? So negative 16 t squared plus 50t plus c. Now remember, we know when we plug in t equals 0, I'm going to go ahead and use this now. The height should come out to be 10. So everywhere you see t, let's plug in 0, okay? So that is negative 16 times 0 squared plus 50 times 0 plus c comes out to be what number? 10. 10. So what does that mean? All these are just 0, right? This is just all 0. That tells us c must be equal to 10. So we have the height function. I wrote too big. I'm going to go ahead and make them a little bit smaller and write down that the height function is h of t equals negative 16 t squared plus 50t plus 10. Okay, I'm going to circle this answer. This is the answer for part A. Okay. Now what's next? What's next? Part B, they said, find the height and velocity of the rock after 3 seconds. Okay, we can do that. We have all the functions we need, so we can do that for them. So let's do part D on the side right here, part B over here. So first, height after 3 seconds is finding h of 3. Negative 16 times 3 squared. I'm plugging 3 into that h of t. Plus 50 times 3 plus 10. I'm gonna see if I have my calculator in my drawer. I do. Let's type this in. Negative 16 times 3 squared plus 50 times 3 plus 10. That came out to be 16, and the unit is feet. Okay, so we found the second answer. This is h of 3. At time 3 seconds, it is up at 16 feet. Let's find the second part. They wanted the velocity at 3 seconds. I'm going to plug in 3 into the velocity function. Okay? What's that going to be? Negative 32 times 3 plus 50. On my scientific calculator, I'm typing this in. Negative 32 times 3 plus 50. That came out to be negative 46. And this is velocity, so let's write the unit correctly. Feet per second. And that is it for this problem. We found the height function or the distance function in part A. And in part B, we use that function to find the height or the distance of that rock after 3 seconds. And we use the velocity function to find its velocity at 3 seconds. So at 3 seconds, or after 3 seconds, this rock is 16 feet above, but it is coming down with the negative velocity, okay? And that is it for example number 6. If I may stop this video somehow.